Hello, everyone. Fulgence here with ATS, and welcome to our live ATS webinar with STI Firestop. It's Firestop Fundamentals. I am your moderator. I'm also accompanied by our ATS team who will support us throughout the event. Today's seminar features one AIA HSW and is valid for the following Canadian provinces: We will report AIA, GBCI, and AIBC credits on your behalf within 10 business days. And if you're a member of AIA, GBCI, or AIBC, please check to make sure your association numbers in your ATS account are accurate so we can ensure a smooth crediting process. And for today's course, you'll get a certificate in PDF form and will be available immediately after entering your session code. The session code is provided at the end of the session. This number will confirm your attendance and guarantee that the credit you earn today will be recorded. And I'm going to walk you through these steps in detail at the end of the hour, so stay tuned for that. Now let's go over a few quick housekeeping notes to help you get the most out of today's session. Please use the Q&A panel for all questions. Please use the Q&A panel for all questions. Please do not submit questions in the general chat. Please use the Q&A. And due to the high volume of attendees today, we may not get to all of your questions during the actual event. So that's why we ask that you use the Q&A panel so those can be added to a Q&A report and you'll get your questions answered offline. If you're in a group if you're watching in a group or a conference room, please make sure that you're each logged in to your assigned Zoom webinar link that was sent to your email. That link is attached to your ATS account, which is how we report credit on your behalf and how we report credits to the correct person. So if you're not logged in yet with your unique Zoom webinar link, please take the time to do that now. If you're ready with your assigned Zoom webinar link, you're good to go. And last thing, if you're having any technical difficulties, try logging out and then back in. We find that resolves 99% of the issues. However, if you have an issue after that, please let me know in the Q&A panel as well. And we will do our best to help you. And with that, please help me welcome John from STI Firestop. John, hello, how are you?
Very well, how are you?
Very good. We have a packed house. We have 500 architects right now, and we're gonna have to we have more coming in. So you have a big event today, John.
That's pretty impressive. I hope you have the large Zoom account.
Yeah, we're gonna need that.
Awesome.
So let me get you all set here, and you are all set, my friend. Take it away.
All right, very good. Well, welcome everyone to Firestop Fundamentals. My name is John Zalepka. I'm the Director of Training at Specified Technologies. You may know us as STI Firestop. Firestopping, it's a real critical role in maintaining the buildings, compartments, protecting lives, right? So a lot of times when there's misunderstanding of this, especially on the early stages of a project, whether it's a penetration, a joint system, any kind of opening in a rated assembly is gonna it's going to affect the integrity of those barriers. So in this session, what I'm hoping to do is to kind of walk you through what fire stopping systems are, how they're tested, what the guide systems say from both UL and Intertek and some of the other third-party testing labs, and then kind of just break it down for real-world coordination challenges so that you can talk to your project teams moving forward a little bit more confidently when it comes to fire stopping. Because at the end of the day, it is about life safety. It is about code compliance. So hopefully we can shed a little bit of light on how to make that easier on y'all moving forward. So it is copyrighted material. Fulgens, I did send you the PDF, so feel free to share that with the listening audience here. It is copyrighted material, so please do not reproduce anything without contacting us first. We do want to spread the good word as far as fire stopping. So anything we can do to help, just let us know. All right, so here are our learning objectives. This is an AIA accredited webinar. It also is a BICSI credit. So if you are an RCDD out there, let us know. We can probably get you some credits for that as well. But at the end of the session here, you're going to be able to clearly identify what fire stopping is, the different types of fire stopping systems, what trades are knocking holes in floors and walls. We're going to talk a little bit about UL listed systems. We'll call them UL for now, but again, third-party tested listed systems. The code doesn't say that they have to be tested at UL, but most of the time they are UL systems. And then you'll be able to recognize some of those key coordinations, as I mentioned, just so you can get your project teams on the same page. So here's how we're going to break it down. We're going to start with talking about fire barriers and the role of fire stopping, which is compartmentation. Then we're going to talk about how barriers are compromised. They're compromised way more than you might think, obviously, with all the different MEP trades knocking holes in the walls. And we'll talk about what the codes say, a system approach. We'll talk a little bit about some fire stopping products, and then we'll wrap it up with Q&A. All right, so as I mentioned, we're going to start by talking about why fire stopping exists in the first place. The critical role that the barriers play in fire safety is compartmentation. This is stopping the fire and the products of combustion and anything else that happens during a fire to their point of origin so that people can get out in time safely. And it works in conjunction with other key fire protection principles that you see here on the screen. It's what we call safety layering. At this point in time, we have a lot of technologies that exist to make cars safer, right? Airbags and crumple zones and anti-lock brakes and power steering. And you don't just make a car with one of these things, just like you don't just design a building with fire alarms and sprinklers. You also need some type of passive protection or containment. So many people are familiar. You can see an alarm, you can see a sprinkler head, but a lot of people don't see fire stopping, that passive piece that just in case the fire breaks out there. And this is where fire stopping lives. It's what we're trying to do is contain the fire and the other products of combustion to their point of origin, because at the end of the day, if you see any type of studies from NFPA, up to 75–80% of people die in a fire from smoke inhalation rather than the fire itself. So what fire stopping is doing is what we see here on the screen. If a fire starts in an apartment there in the middle, we're using the fire rated assemblies and the smoke barriers and smoke partitions, a little bit more on that later. And what we're doing is we're trying to limit the spread of fire to those other surrounding adjacent corridors, other apartments, whatever it is, floor to floor. So this is critical for fire stopping. It supports a defending in place. So if you think about hospitals and other healthcare facilities, people can't physically get up and get out a lot of times in an emergency. So we want to make sure defend in place strategies are in place. And also egress, getting out if you can get out, and then ingress. We want our first responders to be as safely protected as possible. And that's what fire stopping is. It's essentially sealing around any openings that are created by mechanical, electrical, plumbing trades. We'll throw the sprinkler contractors in there. Anybody making a hole in a barrier, we need to make sure that that barrier is then protected. In terms of fire-rated joints, you can see on the right-hand side of the screen there, what we're doing is we're sealing together an opening that's left open intentionally for dynamic building movement, whether it be shear movement, wind sway, just different loads on floors, deflection of walls. We need to make sure that those openings are protected as well. So if you're a contractor, this is kind of what we teach. Grab those life safety plans. If you're on the architectural side, engineering side, which most of you are, you're going to be very familiar with the building plans, the life safety drawings, and this is what we tell contractors to look for. If it's a renovation project and maybe these things don't exist and are trying to fix a wall, we tell them to look for things within the assemblies themselves to say, hey, this is a fire-rated wall, like stenciling, which is part of the code. So this was a 2-hour wall at some point before someone made Swiss cheese out of it. We look for things like fire doors, fire windows, dampers, old fire stopping, and any type of penetrating items. This would identify it as a rated wall. But obviously, if you're on this side of it, the design side, you're going to be the ones coming up with these life safety drawings to tell the contractors what's a 1-hour wall, what's a smoke partition, what's a smoke barrier, what's a 2-hour floor, you know. So this is kind of what we're talking about, and these are the barriers that we're using to contain the fire and those products of combustion. So now let's talk about how they get compromised, because they do way more than people think. If you walk through any building that's been open for any amount of time, what you see is kind of what you see right here. It could be anything: ducts, cables, pipes, you name it. Basically, anybody that's poking a hole in a wall or floor, they probably will. And even after the building opens, there's going to be small renovations. There's going to be the need for cables. We'll talk a lot more about cables in a bit. But this is these are some pictures from actually new construction, believe it or not. So they're doing scab patches around ductwork there. They're using things like expandable foam, polyurethane foam that's actually very flammable. So Let's be crystal clear. We would never condone anything like what you see on the screen here, but we see it all the time. So we figure we'll show you what not to do. So don't let this be you. All right, so let's talk about the MEP folks. Again, your mechanicals, your electrical, your plumbing contractors. Fire stopping is a little bit different than the trades that I just mentioned or that you see there on the screen. It's basically going to be a caulk gun that's handed to the low person on the totem pole. So you think you went to trade school to be an electrician? No, today, son, you're going to be a fire stopper. You're going to be a caulker. So, these are the same folks that are making the holes in the walls that if they're not educated properly, they don't know how to restore the hourly rating that they lost because they poked a hole in it. So we'll talk a little bit about UL and how they define what a penetration fire stopping system is. It's very simple. If you have a wall or your floor, it's got to be rated. You have a penetrating item, so it could be a duct, it could be a pipe, cables, whatever it is. It could just be an open hole. And then you need some materials that are designed to prevent the passage of fire through that opening. It can't just be, like I said, expandable polyurethane foam or newspaper or just something that is flammable. You need you see here a concrete wall that was probably rated, tested for a certain hourly rating. Then you have an opening, a round opening, a pipe coming through there, and some intumescent or maybe some expandable type sealant that's going to close that down. When we're talking about joints, they're kind of compromised a few different ways, right? As I mentioned, you leave these openings open intentionally so that the load of the floor doesn't crack your drywall, so that your two masonry walls don't spall. You're going to put some movement in there because you know that things are going to move over time. These buildings breathe. They have different wind sway, and in certain areas they have seismic conditions. So obviously having movement is paramount to certain joints, but we do need to make sure that they're protected. So for your interior finish joints, you can see the 5 most common ones there: your floor to floor, wall to wall, head to wall is probably the one that people are most familiar with. So just kind of taking a look at the definition and how UL talks about what a joint is. It's going to be adjacent assemblies, right? Head to wall or 2 walls coming together. They both have to be rated. No matter how great the fire stopping product is, you're not going to get a rating to a wall that never had one to begin with. So we need to make sure we have 2 adjacent or rated assemblies, and then the material that you're going to put in that linear opening to stop the passage of fire and smoke through there. So we see pretty typical head of wall joints there with your concrete over steel fluted decking, if you will, and a gypsum wall kind of meeting it, and they stuff it with mineral wool and then they spray it, and that's kind of what we're talking about for your interior finish joints. And then one final area where you're going to see compromised or where you need to protect that compromised area where you have some openings is around your perimeter. So the code is going to tell you that you need to extend the rating of the floor to a non-rated curtain wall panel. Most of the time it's non-rated. I realize in some cities you do have to have rated exterior walls, but for the most part, you're designing these beautiful floor to ceiling glass curtain wall assemblies, and we need to make sure that we could put some type of a system in place there to protect that edge of slab gap there. So what we're doing is we're taking the rating of the floor, we're extending it to whether it's a steel back pan or you're just insulating the panel there on site, or EIFS or a poured in place kind of panel there. We just need to make sure that we're extending the rating of the floor and we're filling that gap so that the fire doesn't propagate on the interior of the building. So those are essentially the 3 categories of fire containment systems, if you will. And we'll talk about now what the codes say as far as why you have to fire stop them. Again, it's life safety, but I can tell you that no contractor fire stops for the fun of it. They just don't. They do it because they have to. I heard one time, and this is a sad thing, but I say it all the time, but building to code is the cheapest way to build something legally. And if you let that sink in there, it's what we're doing here is honestly, we're checking boxes and we're trying to make the buildings as safe as possible. So at the very least, we want to make sure that we're hitting the code requirements. So when you're building to code, a lot of times you're talking about the IBC. So now we have the 2024 edition out. Most jurisdictions at this point obviously haven't adopted the 24 edition, but every 3 years it's updated. So a lot of jurisdictions now are adopting the 2021 code. Obviously, there are places, certain regionals or local codes where you're going to have your own code, which are typically based on the IBC. And then you'll have different operating codes, right? So you'll have the life safety code, which is the 2012 edition. And the reason that I'm showing this is because this is what CMS and the Joint Commission and different accrediting agencies like that for your healthcare and hospitals, they're judging the different type of life safety systems to the life safety code. So you have a building code, you have an operational code. So a lot of times what we say to architects is, hey, design in mind of this. For right now, what they're going to be inspecting to is going to be the NFPA 101, even though your 2021 building code says this. So they're always going to default to the one that's most restrictive. So don't find out afterward which one that is. So here you'll see the different sections where you'll find fire stopping for your through penetrations for your walls and your floor sections, your joint systems, your curtain wall assemblies. So depending on what code you're working in, you'll be within a decimal place or two of these sections there. But this is where you can get all of that information, where you may want to put a certain amount of it into your specification just to kind of call out to say, hey, contractor, don't just put fire stopping in the wall. Do it for this reason because of this. So here, those are those sections. I did mention a little bit earlier, we talked about smoke barriers and smoke partitions, using those to help contain the fire. A lot of times people will just say, hey, what do we do with the smoke walls? And smoke walls, as you see, the code doesn't define what a smoke wall is. So you're going to be dealing with smoke barriers, with smoke partitions. And this is essential for contractors to understand that your smoke barriers actually need to carry a 1 hour fire rating. So when you're specifying or you're designing your building with smoke barriers in mind, just know you're essentially designing a barrier that contains a 1 hour fire rating, and it also stops the passage of smoke. So it needs to have an L rating, whereas your smoke partitions, non-rated, does not have to, but it does need to pass the local authority having jurisdiction to say you can't just put bubble gum in there. You need maybe an approved smoke and acoustical sealant. So there's the differentiation between your smoke barriers and your smoke partitions. Don't call them smoke walls because they don't exist. So since we're talking about codes, we're going to talk about where we do testing. We are a Firestop manufacturer, so there are some others out there as well, and the code doesn't say where we have to do the testing, just that we have to test it to certain test standards, ASTM and UL standards that we'll show you next. So these are three of the biggest testing agencies in North America. So a lot of times people just default and call them UL systems. I would say maybe 95% of through penetration testing does happen there, but there are a lot of curtain wall or perimeter fire containment systems that are tested at Intertek. FM approvals, part of FM Global, they have their own testing lab as well. So there's a whole nother batch of tests over there. So again, the codes don't say where the testing has to be done, just that it has to be done to these standards that you see now on the screen here. So you don't have to memorize them, but I would recommend putting especially these test standards into your spec. This way the contractors know that there are different products for through penetrations and we test them differently. So ASTM, if you think about it, it'll give you your F and your T rating. A little bit more on that later. UL will then take that F and T and build on it and let us test for smoke leakage and water washout. Your joint systems are tested to different standards, right? There's going to be movement like we talked about, and quite frankly, there's not an opening with a penetrating item. It's a joint system. So we have different test standards for the different types of fire stopping systems that you will encounter and that you have to design to. And when we as manufacturers test, we don't just turn the furnace on and let it burn out of control. We test a very specific time temperature curve that this dates back all the way to the 20th century, the beginning of the 20th century, actually. So it's ASTM E119. So when we turn that furnace on, we have to be up to 1,000 degrees in the first 5 minutes. If we're doing a 2-hour test, you can see we're up to 1,850 degrees Fahrenheit. So again, these are the same. This is the same curve that we test, whether it's a penetration, a joint system. This is even the same time temperature curve that they use when they're testing the assemblies themselves. So if National Gypsum has a new gypsum board that they want to test, they're going to put this time temperature curve to that assembly to make sure that their new gyp board is going to stand the test of time. And then when we do that, as I mentioned, the first thing that we're going for is an F rating. This is what most people identify fire stopping with. So your flame pass through, so from that hot side underneath to the cold or the unexposed side above there, well, how long did it last? And most of the fire ratings that you'll see are 1 or 2 or 3 or 4 hours. There are some 30 minutes that have been, specified or called out there. But as manufacturers, we're typically trying to go for at least an hour, if not longer there. So, but F rating, that will be the first thing that you see on there. The next thing that you'll see on a system card is going to be a T rating. This is another rating that is required by the code, and this is protecting the thermal rise of that seal or that space around the seal as the fire hits it, so your unexposed side. So even if that fire stop system there is in place, if you have a cable bundle or a bunch of copper pipes next to each other that are going to get really hot really fast, you're going to have 325 degrees above your starting temperature really quick. So your F needs to match your T unless it meets certain exceptions. So what are those exceptions? That's a great question. So here they are. So the code says that yes, you have to protect the thermal rise through that fire stopping system to the unexposed side, unless it meets one of these exceptions. So a lot of words on this slide. I don't like words on slides, so I'll show you pictures instead. Words scare me, but this is essentially what that code section says. If your penetrating items wind up within the stud cavity of a wall, which they usually do, then you don't have to subject them to a T rating, which would entail wrapping them 36 inches with some high temperature wrap. So as long as they're in the stud cavity of the wall, you're good. Floor drains that are going into like floor ceiling assemblies. So think about like wood framing structures. So if that goes into there, you don't need to have a T rating. And then if you have up to 4-inch conduit going straight into a metallic switchgear, you don't have to protect the thermal rise there as well. That's going to all find its way into that box there. So again, these are exceptions to the code. So if you wanted to make sure that you were meeting those exceptions, have a pre-construction meeting with the architect yourself, with the general contractor, with the installing contractor. So just to make sure everyone's on the same page and they understand that this is an exception, right? So it's not the rule, because the rule is the code, which says you have to protect it. So some optional ratings that we get as manufacturers, as I mentioned, we're going to check the smoke leakage in certain scenarios. So if we have nested cabling, cable bundles, or again, head of wall joints, depending on for your smoke partitions or your smoke barriers where you need that L rating also. We're testing at UL or according to a UL standard to get this L rating. So the code recognizes that we are not going to always have a hermetic seal. So you could see 5 CFMs per opening or up to 50 CFMs per wall of 100 square foot is allowed. So again, we're not always going to get a hermetic seal, but it is some allowable air leakage through that seal. And then W ratings, sometimes it's important where you have plumbing stacks where you may have some condensation issues or pipe bursts. Once you're in full operation, you may want a W rating or a watertight seal on there. This is also good for floor seals as the building itself is going up. If they're using a silicone type product, you can get a W rating where we put a cylinder on top of that seal and put 3 feet of head pressure on there for 72 hours before we burn it then. So this is going to basically expose that sealant, that fire stopping system to water for a certain amount of time, simulating it, sitting on it, and then the building catching fire at some point in the future. So those are some optional ratings that you can put into your specification for certain instances. And then something that we always recommend that you put in the spec these days, and again, it's a code requirement, but you have no idea how many people don't even realize this is a code requirement. So since 2012, there has been a special inspection requirement for fire stopping. So here it is. I show all the code sections because it actually keeps morphing into more and more types of structures that need to have a special inspection. This means not just your local authority having jurisdiction, not just the local code official. They have a lot of other things to look at. So if your building is over 75 feet high, or it's a structure that's of national importance, air traffic control towers or hospitals or key facilities where if you had an emergency, you could have some real devastation. So certain types of buildings, including now wood frame structures or group R occupancies over 250, need to have a person that's dedicated or a company that's dedicated to reviewing fire stopping systems all day long, that's hired by the owner to do that, and then provide a report to the local code official, who then obviously can go and inspect or spot inspect things like that. But Special inspection for fire stopping. This is something that more and more jurisdictions are starting to enforce. But if you put it in your spec, they'll know that it's actually a code requirement and it won't be overlooked as much as it is right now. That's me on my soapbox. All right, moving along. All right, we're going to talk about following a system approach. This is kind of what we talked about, the UL system approach, if you will. We'll kind of show you how to read those numbers. But again, not all fire stopping has to be done at UL. We just kind of default to saying that because a lot of jurisdictions, a lot of AHJs say, just show me the UL system. But again, it's a fire stopping system, but we'll show you some UL systems. Just we aim to please here. You know, we don't want to upset anybody. But basically what you need to know about a fire stopping system is that it's for engineering purposes. This is kind of, it's like a cake recipe, right? It's instructive, but it's not an approval. It needs to be approved as part of a submittal package, most likely, hopefully. You're requiring this from your subcontractors or your general contractors, whether it's part of a full life safety plan or barrier management program or not. They should have, at the very least, you know, if they're going to have a P trap coming out of a wall, they should have this system, WL 1527, as part of their submittal package. So it's going to show you that this pipe can go in the wall on one side and then you're sealing it only. And evidence of compliance is that it's been tested to those standards that we showed you before. So this is kind of what a system looks like, just a simple one pager where you can get away with caulk only, because maybe you have a metal pipe coming through a block wall. So the block wall is not going anywhere for 1, 2, 3, 4 hours. But we need to make sure that if that pipe comes through there, that we are going to seal this opening with some sealant that has been designed to protect that penetrant, that type of penetrant. And if it's plastic, then you're going to need to make sure that you have something that is intumescent, that's going to expand with heat because that pipe is going to burn away. So you need to make sure that it gets very aggressive. So when you're talking about systems, you're going to see up top there, it's always going to be called out what the system number is, all of your ratings. So this one has F ratings. This one also has some T ratings. Your penetrating items will be right here in the middle here. And most of the time you'll see if it's a metallic pipe, you'll have steel pipe, you'll have iron pipe, you'll have copper. So it could be the same system for 5 or 6 different trades, right? Like plumbers and sprinklers and electricians using conduit. This could be the same exact system for all of them. Your angular space is going to be the opening, so it can't just be whatever size they want. It's going to tell you it needs to be a certain size. And then finally, the fire stopping material down there. So if you're reviewing a submittal package and you're seeing some UL systems, you can easily identify that, you know, W tells me that this is a wall system, right? They're not trying to trip anybody up. The nomenclature is pretty easy. So it's going to be a floor, it's going to be a wall, or it's going to be a combination. So there it is. Wall, floor, or floor and wall together. And then the second letter will tell you what type of wall that is. So in this case, your L is going to be a framed wall. So it could be framed with either wood or steel studs. Whatever manufacturer, whatever that they're using is going to stay in the system, whether we used steel or wood studs. Sometimes it's both, sometimes it's either or, sometimes it's only one, depending on the product itself. So you could have a concrete or masonry wall. Those combination systems, as I mentioned, you will typically see CAJ, but that's what that second letter or grouping of letters tells you. The first number that you come to in a UL system will tell you what the penetrating item is. So your 1000 series are going to be all your metals, your iron, your steel, your conduit, your copper, 2000s plastic, 3000s cables, and so on. You can see right there. So, you know, when we're teaching contractors how to install this first thing you need to do is, hey, what's a system? You know, and a lot of times they don't know what a system is, but they all mean something. All the numbers, all the letters mean something. And even the last few numbers mean something. It means who authored or who sponsored that test. So WL1222 is the 222nd listing in penetration fire stop systems through framed gypsum walls, and STI is the owner of that system. And then you'll even see the little dash there at the bottom. A few years ago, UL actually started running out of system numbers, and they didn't want to take away the nomenclature up to that point. So what they're going to do is they're going to actually just add a digit at the end of it. So if you see 5 digits at the end of WL10000, it's not a typo. It's just probably one of the newest systems. All right, and then your joint system's a little bit different than the penetrations here. Again, as I mentioned, You need to have two assemblies that are rated, and they need to be adjacent to each other. So that could be head of wall, that could be bottom of wall. Typically, you'll see a head of wall detail like this when you have steel over concrete fluted decking there and your gypsum wall there. You're going to have some movement. So you'll see class 2 movement where we had 40 or 50% compression and extension. So if you need to have that type of movement there for seismic or wind sway or whatever it is, this was tested for that. You'll see all the other ratings here. In this case, though, you'll see assembly ratings, which means the assembly rating is D equal FNT. Code also says your joint systems have to have an equal FNT. No exceptions here, though, so they're going to call them an assembly rating. On the right-hand side, for our Canadian folks, you can see that we have different standards that we're testing for Canadians as well. So you'll see that they break that out a little bit different with the F and the F and T. And if you know, you know, and if you don't, feel free to reach out and we'll put you in touch with our Canadian crew to help you decipher some of these. But there are some different standards north of the border there. All right, so when we're talking about how to read the numbering system here, your first 2 letters will tell you what type of joint system that you're dealing with. So you can see the perimeter fire containment or your curtain wall. That's lumped into how to read the same system, even though it's a different test standard. So you'll see head of wall, HW, bottom of wall, BW. Again, not trying to trip anybody up. They want to make sure that we're getting this right. The second letter or the second group there, you'll see that's going to tell you if that joint system moves or not. So if you see the D, that means it's a dynamic system. It was tested with that movement, and we'll actually, as the test sponsor, we'll put in what dynamic movement it was achieved there. So sometimes it's a class 1, sometimes it's class 2, and this all depends on how much we're moving, how fast we're moving it. So be cognizant of that. And then there are some static systems as well, whether you're not getting compression and extension because maybe the joint is in the plane of the wall, or maybe a contractor used a product that doesn't move, that was not designed. We do test some things sometimes that we know are not going to move because sometimes they don't have to, and sometimes we know that things happen anyway. So at the very least, we want to make sure that we can get you the F rating that you need for that fire protection. And then the numbers here mean a little bit different in your joint systems. The first number will tell you the width or the how wide it can be. So you can see the 0 series can go up to 2 inches, but the systems will oftentimes be very specific, not sometimes, always be very specific about what was tested. So if it was a 1-inch joint, it would still fall into the 0 series, but you couldn't exceed 1 inch with that particular system. And then as the joint gets bigger, you can see that that first number there will get bigger. And then the same way that the penetration systems, the last 3 and/or 4 numbers go to the individual test manufacturer there. Same deal with your joint systems. All right, so let's talk a little bit about some fire stopping products. Again, we know that this is just one portion of the system. The products themselves oftentimes are, a lot of times contractors will think, hey, give me the 2-hour fire caulk or the 4-hour fire caulk. And sometimes they go down to the local hardware store and then they buy the 2-hour because it says 2-hour on there. But the products themselves do not have a rating. They're just one portion of the fire stopping system. But when you are specifying this, it's good to know, again, how they break out, what the applications are. So you don't just say, put in a tested fire stopping system. You may want to say, hey, put in an intumescent fire stopping system that's designed for movement, right? I mean, you can get a little bit more specific and lean on your fire stopping manufacturers to kind of help you pull together some of that language if you're not using one of those services that are kind of staying up to date on all the codes and standards and different test methods and new products there. So again, here are the different product categories. We're going to talk a little bit about MEP penetration products. We're going to break out data communication penetrations because they're just different animals. I mean, you can see the cables are in sleeves, so they're outside of, MEP penetrations. Unless you have some type of major renovation, you're not moving ductwork, you're not moving pipe, but cables, they move all the time. Our joint systems, as we talked about, both interior finished joints and curtain wall joints, we'll just kind of talk to you a little bit about what types of products are out there and kind of what they do and some of the benefits of each there. So again, we'll start with MEP penetrations. Everyone knows the intumescent sealant. I mean, you've seen this It's some people like to do finger painting all over the wall, but what we're trying to do is we're getting that sealant in the annulus, flush with the surface. So you could see a typical plumbing contractor here getting the sealant in there and using a tool to get that flush with the surface there. So intumescent sealant, it's a flexible, fire-resistant material. It reacts by expanding with heat or intumescing. It's going to form a thick char there. So it's great for metal pipes. It's easy. Metal pipes aren't going anywhere, but it's also good for certain smaller size plastic pipes. But when you get a little bit bigger with your plastic pipes, the sealant alone is not going to be able to crush that PVC pipe. So in certain jurisdictions, PVC is perfectly acceptable. It's easy to use, it's easy to put it together, it's lighter weight, but from a fire stopping standpoint, it's going to burn away. A PVC pipe is going to be gone in 7 to 10 minutes. So if you have a 4-inch PVC pipe there, you're going to have a 4-inch hole in about 7 to 10 minutes, unless you put some type of fire stopping system that doesn't just have a little bit of sealant around there, but it has a pipe, a collar for a pipe specifically designed to crush that pipe. And you can see what it does here on the left, the hot side, the hard ash char on the right side. It's ASH. I wouldn't curse in front of y'all here. But what it does is it's going to crush that pipe. It's going to seal. It's going to intumesce really fast, really rapidly. This is why you have to have certain fasteners on the wall there to make sure it doesn't blow off the wall. But you can see on the cold side, that PVC pipe, it continued. So, from a T rating standpoint, this is also another great building product to work with there. You just need to make sure that you have the right type of fire stopping systems when you have pipes that will burn away in 7 to 10 minutes. So data communication, we'll talk a little bit about the types of products here. These are types of penetrations that you're going to have frequent moves, adds, or changes. So if you think of, upgrades in Wi-Fi, or maybe you have a new office that needs some Wi-Fi, or you're expanding the network coverage, or cables are going to be added, they're going to be moved, they're going to be rerouted, and the frequency of change can vary depending significantly on the building's occupants. You can have new occupants, and all of a sudden you have to redo everything, right? It's always evolving. You're always going to have upgrades and cables, so you need to make sure that you have fire stopping systems or products that allow for these high traffic openings to meet that flexibility that they need. So historically, putties have been the go-to solution for data cables. Perfectly acceptable. They're soft, they're conformable. They don't harden. Well, most manufacturers don't harden over time. They're manually packed into the openings, so they're specifically useful for small cable bundles where you're going to need to get back through there at some point in time. Let's call it medium size. But once you start getting, a little bit more too much, then you're going to turn that sleeve into something that's overfilled, right? So when you have data cables, you have something that's flammable, right? You have plastic jacketing around there. So these sleeves are going to have some type of cross-sectional fill maximums of around 48%. So I don't know if you've ever been on a job site and saw a sleeve with more than 48% fill, but I can tell you it happens all the time. So if you have a 4-inch sleeve, for instance, you really can't have more than a 2-inch bundle of cable going through there because, again, over time, it's tempting to just run something else through there. Or if you are upgrading, next thing you know, you have something that looks like the far right, where you have no intumescent material and you have nothing but cables. So what happens is you're stuck using a retrofit device, and that's why they were invented. So in the past, historically, you didn't have an answer outside of taking half of those cables that were already connected to something that is in the building, they're already in operation, making a new opening and fire stopping them both properly under 50% fill, let's call it. But now there are retro devices on the market there. So this is ours. You simply snap it over the end of the overfilled sleeve, or it flush mounts to the wall, and you can bring that overfilled, non-compliant, life safety issue back to compliance in about 15 seconds. But why do that to yourself in the first place? Avoid any kind of hassles of overfilled sleeves by using fire-rated devices from the start. This is our device here, and it's pretty cool. With a little cutaway, you can see how it opens, it closes. It allows for maximum cable fill of 100% visual fill, All of the intumescent material is inside of that box. So it's a sustainable solution. You don't have to maintain it, so it's zero maintenance. You don't have to do anything to it. You can just route cables. Contractors even use pull strings in there so that they don't have to go popping ceiling tiles. If you're doing work in healthcare facilities, you know how that could be a big issue there. So cable rated pathways, just something a little bit easier for when you know that you're going to have a lot of cables in there. So maybe maybe you're doing work in a data center, or you want some of the flexibility so you can see here, you can just load them up. You can have them for different types of services. You can leave the pole line that you see on the right hand side there in there so that you don't have to keep going up above the ceiling tiles. You can coordinate them in the floor. So if you're going to have a lot of lines coming through there, or maybe you're going to have some future moves, adds, or changes, you can kind of just have it ready for that type of upgrade later on down the road. But again, 100% compliant, 100% of the time. Check out UL's evaluation service report. That's not us saying it. All right. So construction joints, we're going to talk a little bit about some of the contractors that leave these joints open intentionally because of your designs, right? Drywall, masonry, curtain wall type contractors. Again, you're designing these joint systems typically to allow for some type of a building movement there. So you can see your head of wall there, concrete over steel fluted decking, meeting that gypsum wall. So they're packing the flute, they're putting a little strip of mineral wool in there, and then a contractor is coming along with some type of an elastomeric. So this is a different product than your intumescent, which will expand with heat. Elastomeric often will move with that joint there. So if sprays are going to move a lot more than your typical caulking systems, contractors do like the caulking systems for smaller joints or smaller linear runs, or people who are crazy and like to get up on scissor lifts anyway. They're going to just caulk that joint up top there. It's a little bit smaller. It involves not bringing a spray rig onto the site there. So sometimes, you know, architects will ask not to have spray in the building or near the curtain wall glass. So joint sealant systems are perfectly acceptable in these situations as well. But if you want any of that, you can actually fire stop the joint system without any sealant, without any spray, by using a gasket. So this is fire stopping as the wall is being built. So someone's got to get up on a lift or a ladder anyway to shoot that track. This is a gasket that is rolled out on the track and shot to the ceiling or the wall. Joint systems just a lot easier. It makes movement a lot better too. You don't have sealant or any type of mineral wool that will restrict the movement, so you'll get 100% compression and extension using these types of gasket. And zero waste also for the contractor. So if cost is an issue, might be something to look into. Not that cost is ever an issue, right? All right, and finally, perimeter fire containment systems. Some of the products here, there aren't a lot of different types. There's a water-based, latex-based product, and there's also something that is a silicone or a cold polymer hybrid type of a sealant that stops the water from going through there. So we'll show you a couple of those here. So a building's facade, often very distinctive, and we get it. You want to make these buildings as beautiful as possible, floor to ceiling glass, vision glass. You can't even, don't even want to see the floor line, but there's always going to be a floor line, right? And this is where we put those fire stopping systems in. So there are some testing that just keeps going, right? It doesn't stop. I mean, not one curtain wall is the same as another. So we want to make sure that we're putting some fire protective systems in place early on. So we tell architects, hey, listen, this is something where you should get your manufacturer involved very early, because these curtain wall panels oftentimes are designed and manufactured years ahead of time, sometimes before a GC is even selected, before they even break any ground. So let's talk about how we're going to make sure that these systems are protected once these panels get on site, because once they get on site, I can tell you from experience that it can be very cumbersome, very expensive to get a tested system in place, which some jurisdictions require. Sometimes engineering judgments, which we do all day, every day, especially for perimeter systems, they're not accepted sometimes. and it could be change orders in the hundreds of thousands, if not millions of dollars. So get your manufacturer of choice involved early on perimeter fire containment systems, especially. And again, that's my PSA on that one. All right. So, Fulgence, I talked fast because I'm from New Jersey. So we could do this a couple different ways. We could ask questions of me right now, or I could ask questions of the listening audience if you're okay with me doing a small little quiz to a fun little game. You let me know.
All right. So we have 15 currently open questions right now in the Q&A. How do
Okay.
you want to go about that?
Let let's knock those out first, and we'll leave 5 minutes to do the game because people like the game. I
Yeah,
promise you. And if you're okay
definitely.
with me doing the game, then I want to do the
Oh
game.
yeah,
So.
we have like a record here of like 700 people in here, so they deserve a game. They
Holy.
deserve a game for sure.
All right, well, I'll go to my question slide. Here's my question slide. And not to toot my own horn, but I did write a book recently. It's called The Presenter's Playbook. So if you need to do any type of technical type of presentations like this one here, keep it kind of fun. It's available on Amazon. That's it. That's my sales pitch. But let's go with the questions.
Awesome. So the first question is fireproofing and fire stopping different?
Yeah, so they're completely different. Great question, though. A lot of times people get them confused. So fireproofing is going to be what you're spraying on those big beams to make sure that they don't melt so that the building stays up there. Sometimes those fireproofing comes in contact with fire stopping as those fireproofed beams go through a rated wall that's part of the ceiling. So we need to fire stop or seal around the fireproofed beams. So that's kind of the easiest way to think about the difference.
Awesome. Next question is can we find your products in Montreal, Canada?
You can, if you send me an email right there, jzalepka@stifirestop.com. Just let me know where you're at, and I'll connect you with our local territory manager, regional manager to help you out.
Yeah, thank you. Next question is this more of a smoke stop than a fire stop?
It's both. So it's if you see the little thing all the way down the bottom, it says fire stop, smoke, and sound solutions. So when we're fire stopping properly, we're also stopping the smoke. Sometimes we're testing for the smoke in that L rating, like we showed you a little earlier. Sometimes it's not always a code thing, but when you fire stop properly, you're usually stopping the smoke also.
Awesome. Next question is should the location or notation of fire stopping be shown on life safety plans?
That's a great question. It should. I think it should. The more places that you can put in on the architecturals, on the drawings, to make sure that people can see what the systems look like, not just read the words on a specification. Now, I can tell you, lawyers, they like to read words a lot more than they like to look at pictures, whereas contractors might be the opposite. So having both is important because no one ever wants to think about legal, but legal lawyers are going to look at words. But contractors need to know, what to do. And a lot of times having an illustration on a proper fire stop system can help them also.
Excellent. Do you have a fire stop details selector on your website?
We do, and I owe you 20, whoever asked that one. No, but yeah, it's on STIFirestop.com. If you just go to that main website, so it's the rest of my email address there, you can see something in the upper right-hand corner. It says system selection. Just go on that and you can just play around. You can't break it. If you make yourself an account, I do have a QR code that'll take you directly to there, but it's really easy to use, super simple.
Awesome. I've dropped that link in the chat for everybody there. Next question is can you talk a bit about fire rated ceiling assemblies?
A little bit about fire rated ceiling assembly. I can talk a lot about it, but I don't know exactly what you want to know. I mean, so there are floor ceiling assemblies. Usually that's in a wood frame structure. There are some differences to your steel and your concrete type of structures. Depending on what your exact question is, this probably isn't the platform for it. Shoot me an email, and depending on where you're at, we can get you sorted out with a territory manager to look at your details specifically.
Awesome. Can you elaborate a bit more on the curtain wall joint fire stopping systems? Are they intended to support any furniture or weight, carts, etc.? Or are they always intended to be covered by stud space or an overbuilt floor system?
Yeah, so usually the fire stopping system at the floor line there is covered with some type of flashing, some type of wall is built in front of it. So it's not typical that you would put anything. I mean, you can't put anything on top of it, including self-leveling concrete, which is what happened on a project that I was on. They just wanted the floor to look perfect, and it went on top of the fire stopping system, which is not how we test it. So and also, as the systems are exposed during construction, oftentimes a ladder will find its way into that sealant there, so that needs to be repaired as well. And the code says that the systems need to be inspected before they're covered up. So if you are going to be putting that flashing or that wall in front of your system there, make sure that it's inspected and signed off on before you do, or else someone's going to be taking it apart.
Awesome. All right, John, let's do a quick time check. It's 12:51 p.m. Eastern right now. I'm going to do session code review at 1:05 p.m. So we still have about like 15 minutes. So how much more time of Q&A do you want to do?
Let's go. Let's go
All
another
right.
5 minutes. I like Q&A. This is
Okay.
the fun part.
Awesome. Are dedicated fire stopping inspections required in Canada?
All right, let's stop with the questions. I don't want any more questions. I don't know. That's a great question. And again, if you send me an email, I'll put you in touch with our Canadian representatives up there. It is, it's a code. So if the IBC is adopted in that jurisdiction, then it would be a code requirement in Canada there. But I know that the Canadian code, oftentimes they have their own code, which is not always the IBC, but I'd be speaking out of the wrong side of my mouth if I said the answer. So, but send me an email and we'll get you the right answer.
Awesome. Our next question is, are you saying each individual ME subcontractor needs to submit a FS system for their portion of work?
They should. So some jobs and a lot of specifications will call out for one contractor to do all of the work, and you'll typically put a FM 4991 qualification or a UL qualified contractor, that type of language in your spec. In which case, you're only looking at one fire stopping submittal from that one contractor who's going to do all the mechanical, electrical, plumbing penetrations. But if it's left open, which oftentimes it is, and that is even the general contractor they'll ignore your specification. I'm not saying it, but sometimes they won't hire an FM 4991 and they're going to have the plumber do it, the electrical do it. They're going to have them handle all their own holes, in which case, yes, you should have a fire stopping submittal from each one of those uh, contractors.
Awesome. Can a fire stop system contain bundled penetrating elements such as multiple conduits or pipes?
Yeah, so there are some systems out there that allow for mixed multiple penetrations. They're going to be found in the 8000 series. So from that slide that I showed a little bit earlier, if you see an 8000 series, it usually will have a bunch of different elements in there, and depending on the setup, and again, manufacturers test different scenarios depending on the commonality of them, if you will. But it's take a look at the system. It's the answers are always in the system.
Awesome. There was a question about a slide of the table of ASTM standards is not included in the PDF handout. If you could please forward that. What
What?
page was that on? Or
Um,
yeah, the slide of the table of
that's-
the ASTM standards is not included in the PDF.
it would have been on 24. It's my 24 slides. It would have been on slide 12.
Slide 12. All
I'm
right.
guessing.
We'll just leave that. So if it's just double check if it's slide 12. If not, then we'll follow up with that. What type of fire stop material is required for PEX water piping?
So that would probably be in the 2000 series if it's a plastic pipe there. Again, from the system selection submittal builder there, and we can here you go. It's on Access STI. If you click on that QR code right there, you can create yourself an account on Access STI or just look at some of the digital tools that are available, and that system search and system selector will be one of the tools on there. So if you just scan this, click system selection, you can choose penetration, floor or wall, and then non-metallic penetrating item, and you'll see where that PEX is in there.
Thank you. And joint systems, gaskets, do you still need the Elastometric fire stopping, if it is a metal deck above the partition to fill in the cavities, is there a chemical compatibility concern if required?
Yeah, it's not really recommended for that gasket product to be used in the fluted deck scenario there. So it would be more of a flat slab product.
Is gasket installed at the time of the metal stud wall assembly?
Right. Yes.
Awesome. It is 12:55 p.m. John, what do you want to do?
All right. Let's do the fun game, right? Let's
All
do the
right.
fun game. Let's see here. All right. So what we're gonna do is I'm gonna display a QR code in a moment for you to scan with your smartphone. Alternatively, if you're looking at another screen, maybe you have a setup at your computer there, you can go to kahoot.it and you'll see a PIN number that's displayed with the QR code on the next screen there. And what we're going to do is I'm going to do a little Amazon gift card for the winner. How about that? So put your first initial, your last name in there, and then if you're the winner, we'll just have you give Fulgence your email address, and we'll give you a little gift card there. I'm feeling generous, right? All right, so quickly answer, but you also have to be accurate. So let's have a little bit of fun. Let's see. Where is my, there it is. So there's the QR code. So go ahead and scan that. First initial, last name. This way we know who you are. If you don't care about winning, be fun with your nickname. That's cool too. But it is make sure it's safe for work, as they say. Oh, where's my music? Fulgence's always got music. He's got the cool stuff. Make sure I got the cool stuff. Yeah. Wow, look at all these people playing.
Oh yeah. Oh yeah.
I don't know. You were right. There are hundreds.
Don't break it.
Good thing I went with the paid version.
Oh yeah. You got to in these situations.
Well, this is a record.
Yeah.
I have to say. ATS is the best. All right, what should we get? How many are we getting to? We're already over 300. All right, we'll go to 316. If you know, you know.
Hey, right.
All right. I started at 316.
316.
And if you're watching this on your phone, first of all, you can't play, but be careful.
Right.
I saw 316. There it is.
It's like fluctuating.
Right, it won't do it. There it is. All right, we got it. We don't have it. All right, we got it. We're starting. Here we go. We're starting. All right, 5 questions. See how well everyone listened. All right. Firestop fundamentals. We put the fun in fundamentals. All right. All right, question number 1. All right, which fire protection layer contains fire and smoke at the point of origin? Contains fire and smoke at the point of origin. Is that early detection, active suppression, passive protection, or emergency response?
Wow.
6 seconds, get those answers in. All right, 94, you got that one correct. Passive containment is the correct answer, otherwise called fire stopping. Arnold Palmer in first place. No, probably not, but if your name's Arnold, that's even cooler. All right, question number 2. What is the minimum fire resistance rating required for a smoke partition? What is the minimum fire resistance for your smoke partition? 30 minutes? 1 hour? 2 hours? Or is it not required? Somebody's kicking themselves in the answer a little too quick. All right, yes, 81 are correct. It is not required. Smoke partition ends with an N, not required. Smoke barrier ends in an R, it is required. So 145 of you kind of had it right for the smoke barrier, but in this case, not this question. All right, CB jumping to the top of the leaderboard. I like it. L. Segelman. I'm not even going to try to pronounce those. Okay, question number 3. The standards ASTM E814 and UL 1479 correspond to which type of fire stop tests? Are we talking about construction joints, roof penetrations, curtain walls, or exterior wall assemblies? This is the slide missing from the PDF, so I'm sure someone's not. I think it's in there. ASTM E814, yes. All right. 168 people got that one right.
Wow.
Yes, that's right. That is CB got it right too. All right. And N Haven's coming up quick there. All right. Question number 4. This is going to be a slider. It's going to be a number. Make sure to lock it in. According to the time temperature curve, what is our furnace after 2 hours? So it's going to be somewhere between 1,000 and 2,000 degrees. This is Fahrenheit. If you can spell Fahrenheit, you get extra credit. But make sure to hit submit once you get that answer locked in there. And we're not really giving extra credit for Fahrenheit. If you know how to spell it, you're okay. Let's see. 1,500 degrees? No. All right. I think it's a little hotter than that. 1,800 degrees? Oh, 1,850. Whoa. Let's see how many people got that one right. On the number, 10 people got it on the number. If you guessed within this box here, you got some points, but 10 people got it on the number. Let's see who they were. L. Segelman in first place. Last question coming up. Question number 5. Why do high traffic openings require special Firestop solutions? Is it because they're exposed to extreme temperatures? Are they larger than typical penetrations? Are they used for structural reinforcement? Or do they change frequently due to evolving data cabling? High traffic openings. Not the toughest question in the world. Just got to read all the way to the end there. Yes, best answer there is they change frequently. So high traffic openings. Let's see who got it right. Okay. Here's our podium. All right, in third place, Kay Whitmore. In second place, Kay No. And in first place, L. Segelman. You know what? I'm actually feeling very generous. So if you are these 3 people, send Fulgen your email address right now. I'm going to send all 3 a gift card. How about that?
Nice.
Congratulations
to the winners.
Yes. Congratulations there. All right. That was fun. All right. We have a couple more minutes. How do we end this, Fulgen?
I have to do the session code stuff at 1:05, so we have about 3 minutes.
Okay, perfect.
Yes, sir.
All right, let me just, can I tell you about STI a little bit?
Go ahead.
All right, cool. So STI is a global company, worldwide manufacturer of fire stopping products. It's our only game. We don't make cool tools. We don't make any kind of Post-it notes or anything like that. We just make fire stopping. We're globally based in beautiful Somerville, New Jersey, which is about an hour west of New York City. We do trainings at our global headquarters 4 times a year. We also do 2-day trainings throughout the country as well. Up in Canada, they're doing some trainings over there as well. So if you need some training up there, we can help you out. And then globally, you can see some of our offices around the world where we have some representatives that can kind of come out and see you and, again, help you with any type of fire stopping questions. It's always good to get us involved early. We've been around since 1990, so we have 35 years of doing this. And again, as I mentioned a little bit earlier, Access STI, this is where you can go for all of the digital tools that we have available. We have guide specifications, which are downloadable Word documents. So if you're having, some issues with that, we can even do a spec review service for you. We have some field engineers that can kind of take a look at your plans and kind of make some recommendations on what types of systems that you can use. Basically a barrier management program, right? So if you do have the different trades, electrical, plumbing, mechanical, we can get them all on the same page. We have some tools. So you'll see if you're on Access STI, we have something called Firestop Clash Manager. So if you're using Revit in BIM, you can actually tell your contractors downstream, hey, you're going to be using this system based on our model. We found a detection here and generate openings report. So we just have a lot of tools that are really easy for you to use. And if you ever have any questions, you can get in touch with our engineering support. We have a chat function on our website and our app. Feel free to get in touch with them there or email them or old school, pick up the phone. It's toll free. I don't know if that's a thing anymore, but it's an 800 number. So if you want to talk to a human, they'll pick you up and get you moving along. That's 104. How much? Well, with 7 seconds, you put the 105 up there. There we go.
Oh man. John, thank you so much. This is great. And we can't ask for a better start to 2026.
Oh, stop. I appreciate you saying.
Oh man, thank you, my friend.
All right.
Awesome. All right, everyone. Here is your session code 169 176 169 176. For those of you who are brand new to the session code process, first of all, welcome. And I'm going to go through how you can enter and submit your session code so you can get your credits and download your certificate, which is in PDF format. I've also added a copy and paste into the webinar chat for you to follow along with the steps. All right, if you prefer that. So let's do that now. All right, 169176 is your session code. Do not enter it any other way because it will not work. In order for you to receive your credit for the course today, you need to enter the session code into your ATS account at atsseminar.com. Log into your ATS account, enter the session code, complete the course survey, and let's break it down. So you can go to atsseminar.com, or you can use the QR code on the screen to download the ATS mobile app, available on both Apple and Android. Log in using your email address and your password, the same info that you used to register for today's event. And if you get to the website and it says My Account, that means you're already logged in. Just go ahead and click on the red My Account button, and that will take you to today's agenda. And on the screen, you'll see the dark blue Enter Session Code button next to today's course. Go ahead and click on that, and that's going to take you to the session code box right there. And that's where you're going to enter that 169176. And keep in mind that our system closes out the event within 24 to 48 hours. So you have plenty of time. We recommend you enter those codes by the end of the day, so there are no issues with processing the certificate into your ATS account. And once you're done, click on the dark blue button, and that's going to take you to the course survey. This is the most important part of submitting your session code. You have the 6 multiple choice questions and 1 open-ended question for presenter feedback. Do not skip these steps. You do need to provide feedback in order for your session code to process. And once you're done, click Confirm My Presence button. And if you have issues with that, just continue to try. It might take a little bit because there's a high volume of you today. So just be patient with that, but it will work. Once you hit the Confirm My Presence button, that's going to take you right back to your agenda for today. If everything was entered correctly, you should see presence confirmed and no longer enter session code button. Yeah, you guys are crashing the site. There's so many of you today. So just please keep the session code and save it. If you're having issues, come back to it later, okay? And that's it. If you have any questions, please use the Q&A, but please be patient if you're having any issues, because there is a super high. You guys broke our attendance record today, all right? So just please be patient with that. Okay. So once again, once you've entered your session code and confirm your presence, you will now be able to view and retrieve your certificate, and click on the certificates button in your dashboard. And once you click on that, you'll see the courses you've taken with us at ATS, and next to today's course, you'll see a certificate icon, okay? And when you click on that, here is what your certificate will look like in PDF format, all right? And if you want the handouts for today, which was the PDF presentation, that is in the Download Handouts button. Underneath, enter session code, or it should be now presence confirmed. And that is it. If you need any last-minute credits as well, please visit our ATS on-demand course catalog at atsseminar.com. And we'll love to have you as a part of our LinkedIn family for our weekly video updates and our live video podcast on LinkedIn called Built for This. We have our next episode next Friday at 2:30 p.m. Eastern. We'll love to have you there. I will address everyone's questions if there's anything pending. Once again, it's 169176. 169176 is your session code. Thank you for joining us. I'll hang around for questions. Enjoy the rest of your day. Thank you for an amazing first event of the year. And here's what's coming up next at ATS. Hello everyone, Fulgence here with ATS, and as always, I'm joined by Jen, and we're here to highlight what's coming up next week. Hello, Jen.
Hello, Fulgens. Yeah, we've got 2 events next week. One free webinar, which is going to be on Wednesday. That's the 21st. And it is about non-combustible and NFPA 285 tested wood aesthetic technologies for commercial projects. So definitely check that out. It's valid for 1 AIA HSW and 1 Canadian LU. And you know what? I think it is valid for GBCI, which is USGBC and CAGBC. So definitely check that out. At the end of the week, on Friday, the 23rd, we have our Built for This monthly podcast. And I am so excited, Fulgens, because we've got Ann Edminster as our guest. And for you folks tuning in, Ann is our partner in Net Zero, in our Net Zero events that we have each April. And we are going to ask her a ton of questions about what it means to be Net Zero, what it means to, strategies to build to Net Zero. So you definitely want to join us for that.
I'm excited for that as well. And you can join us live right here on LinkedIn next Friday at 2:30 p.m. Eastern. And if you want to participate in the GLM webinar, you can sign up today at atsseminar.com. Look forward to seeing you next week.